Okay, the first topic that we're gonna be seeing in chapter 9 is going to be, well, it is called changes in temperature and phase, but I like to call it specific heat capacity. Okay, first we define what specific heat capacity is. It's a topic that people dislike. I don't know why. I love it. It's one of my favorites because we see it every day. Okay. Um, Specific heat capacity, according to the substance, okay, it's gonna be the energy that is required to change the temperature of that substance. For example, 1 kilogram of that substance by 1 Celsius degree. So, for example, I have an object that has a specific mass, whatever mass. Let's say that that object has 2 kilograms of mass, okay? And that the temperature of that object is 24 degrees Celsius. So with this topic, I want to know how much energy is required if I want to heat my object to a temperature of 28 Celsius. For example, how much energy I need to raise the temperature of this object that has a mass of 2 kilograms. I mean, the object is still 2 kilograms, but I need to know how much energy is required to raise an object from 24 to 28 degrees Celsius. That's the general idea of that, of how this exercise are gonna be about. Now, all that energy required to do this change is known as a specific heat. It's going to be denoted by the letter C subscript P. Okay, CP. Now, as already told you, it is about how much energy. Okay, how much energy. So it requires energy. It requires for us to know the mass of the object and also what is the change in the temperature. What is the change in temperature? For example, in this example that I gave you, what is the change in temperature? How do you get a change in temperature? How do you get delta T? That is a change in temperature. It's final minus initial. Final temperature minus initial temperature. That is a formula that you are already familiar with. Okay, now the specific heat capacity is going to depend on the substance. So I'm going to give you here a list of specific substances. And of course, the exercise will indicate what substance is about. Okay, and for example, we have some metals. Okay, but we also have some liquids, and even though we have steam, okay, vapor. So you can see that all these objects have a unique specific heat capacity. That's very specific. Anyways, take a look to the units that specific heat capacity has. So CP is the specific heat capacity is going to be measured in joules over kilograms Celsius. So energy is measured in joules, mass that is measured in kilograms, and change in temperature that is going to be measured in Celsius. So if by any chance I give you a different temperature, you have to convert to Celsius. Imagine that I give you Kelvins, you have to convert to Celsius. And okay, this is scientific notation. Okay, so in your calculator, 8.89 exponential 2, 3.87 exponential 2. Or you can just move 2 decimal places to the left. Okay. Or you can just say 199, 387. I like it a lot more like that. But anyway, these are specific heat capacities. This topic is also known as calorimetry. Okay, exercises about specific heat capacity are known as calorimetry. stoichiometry, calorimetry. I don't know. They have the suffix in common. The other thing in common is that people don't like it. But I like it. Yay. Anyways, in this simple problem, it says 0.050 kilograms metal bolt is heated to an unknown initial temperature. You don't know the initial temperature of it, okay? But it says that then it is dropped into a calorimeter that contains 0.15 kilograms of water that has an initial temperature of 21 degrees Celsius. The bolt and water then reach a final temperature of 25 degrees Celsius. And then it says, if the metal has a specific heat capacity of 899 joules per kilogram Celsius, find the initial temperature of the metal. So, first, the problem is giving you the word problem. And in this problem also contains a lot of information. Okay? So, what data can we gather from this word problem? What is the first thing that the problem is giving me?
Mass of weight.
The mass of what?
Of the metal bolt.
Aha, okay, the metal. Okay, so in this kind of exercises, we need to separate our givens into the two objects. Okay, calorimetry is about reaching the balance. Okay, between two objects. One object that is the one that is going to be hotter. In this case, is the bolt, and the other object that is going to be it could be water. Or it's going to be a liquid. Okay. Anyways, you can have two objects here. One object that is the bolt, the metal bolt, and the other that is water, okay? So, my recommendation is that you separate your givens, okay? Metal bolt and water. What do I know about the metal bolt?
The mass.
I know the mass, okay? So the first given is the mass. That is 0.050 or 5 kilograms. That is the mass of the metal bolt. It's heated to an unknown initial temperature. The problem is telling me already that the initial temperature of the bolt, we don't know it. Okay? So, the initial temperature of the bolt, I don't know it. Okay? It's unknown. Then, it is dropped into a calorimeter containing water. How much water?
0.15 kilograms.
0.15 kilograms of water. So that is my other substance. So what do we say? Okay, the mass of this water is 0.15 kilograms. Okay, what else I know about water? It says with an initial temperature of 21 Celsius. So this is not a bolt, because from the bolt we don't know the initial temperature. Though we know the initial temperature of water, that is 21 degrees Celsius. What else I know about water?
The temperature, the final temperature of both.
Of both, and that's important. Okay, what you said is exactly what I wanted you to say. The bolt and water, I mean the two of them now combined. Okay, now like you can see here, they are combined. The bolt and the water, they are combined now. And what happens? They both then reach a final temperature of 25, degrees Celsius. What does it mean? That the temperature is the same in both, okay? And it's always gonna be like that. In calorimetry, the two objects are going to reach a common final temperature, because after you put them together, they find their own balance in temperature. They combine, and then they are treated like a whole system. So the final temperature is going to be the same for both objects. We have 25 Celsius, not only for the boat, also for the water. Okay, it's the same in both. And then it says if the metal has a specific heat capacity, so that specific heat capacity, where I have to write it? In the metal bolt or in the water?
The bolt.
In the bolt, okay? So if the metal has a specific heat capacity of 899 joules kilogram Celsius, so the bolt has Cp equal to 899 joules per kilogram Celsius. Find the initial temperature of the metal. So I need to find the initial temperature of the metal. That's my main purpose in this exercise. Okay? That is my main purpose. I don't know. Do you hear me? Guys? Do you hear me? Jesus Christ. Well, I'm sorry guys. I don't know what happened with my connection. Can you guys hear me?
Yes.
Okay. Bueno, I was saying that the metal bolt, has the specific heat capacity of 899 joules per kilogram Celsius, and then the problem says find the initial temperature of the metal, which means that we're going to focus on finding the initial temperature but of the metal bolt. Okay, now the specific heat capacity of water, the problem doesn't give it to me, but I know it's water, so I'm gonna use my table of specific heat capacities, and I know that for water my specific heat capacity is 4.186 times 10 to the third power joules per kilogram Celsius, or if you want to write it without scientific notation, it is, I'm telling you this because we're going to be using water a lot, okay? Some people don't like to write scientific notation, for example. So people prefer to memorize it like this. Okay, 4,186 joules per kilogram Celsius. That is water, and I'm gonna write it here in my givens, okay? Even if it's not given in the word problem, but it's part of the given, okay? That's why you have the table of the specific heat capacities. Okay, so this is the way to do it, okay? This is exactly what you need to find everything. Okay, you need to know the specific heat capacity, okay, of both. So how do we work with calorimetry? Calorimetry is about conservation of energy. You're gonna hear this a lot. Conservation. Conservation means that your initial condition is going to be equal to the final condition. That is conservation, okay? Now, in calorimetry, we're going to have two objects, and that's why we separate our givens like this. So, we're going to say conservation. The main equation is this one. Okay? So what does it mean? Q gain equals to negative Q lost. In other words, this means that the energy that was gained in the system is the same that the one that is lost. And that's why we separate our givens like this, metal and water, because one of them is going to gain energy and the other one is going to lose energy. Okay, so we need to analyze. In every calorimetry problem we are going to need to analyze, okay, what object is gaining and what object is losing. So I'm going to give you a tip, an important tip. Which one is going to gain and which one is going to lose? Gains the one that has less initial temperature. Well, which one is going to lose? Is going to lose the object that is the hotter object, okay? So we analyze this problem and we need to analyze which one is going to lose. What object is hotter than the other? Even if we don't know the initial temperature of the bolt, for the way it is written, we can identify which one gains and which one loses energy. It
The
says,
water loses.
it says the metal bolt is heated to an unknown initial temperature. So what happens when you apply heat on a metal?
It gains temperature.
Okay, yeah, I know. Okay, I know that the one that is being heated is the one that in that moment is gaining temperature. But in the moment when you mix them, when you put the two together, the one that is losing is the hotter object, which in this case is the metal. Okay, why I know that the metal is hotter? Because the initial temperature of the water is 21 degrees Celsius, is a cool temperature for water. Okay, and if you apply a heat to a metal, it's going to be greater than 21 degrees Celsius, because 21 is a low temperature. Okay, 21, I mean, if we are in at 21 degrees Celsius here at San Pedro or in Villanueva, you're going to be wearing a sweater. Okay, so 21 degrees Celsius, this is a cool temperature. And so from the two objects, the water is going to be cool. Okay, so what happens with the water? What happens with the water? What is the final temperature of the water? We can see it even from here, from the temperatures. What happened with the temperature? Increased or decreased? The final temperature. How is the final temperature according to the initial in water?
Increase.
Okay, increases. What does it mean if it increases? That means that the metal bolt, was really hot, that had to increase the temperature of the water. That is an analysis that you can do. Okay, so because my final temperature is greater than the initial temperature, this one is the one that gains. Okay, so what happens with the temperature? The temperature increases, so this one, my water, is the one that gains, and my metal object is going to be the one that loses. Because why you will put the metal bolt in the water? Because you want it to get cooler. Okay, so that is the analysis that you, and that's why people don't like it. But just imagine, um, Imagine that you have to forge a sword. But how do they do that? They apply a lot of heat. And then to make it stronger, to make it a lot more resistant, after they apply heat, they put it in water. Why? Because they want the sword to lose temperature. Okay? So water is used to lower the temperature of metals. That's something that you have to know. So usually people like to learn it like that. Ay, no, yo me lo voy a aprender así. People tell me that water gains. Yes, water gains. That's all you want to know, okay? Water gains. But I don't like to teach it like that because it's not always going to be water. Sometimes it's going to be a tea, for example. So it's not always going to be water, but yeah, in general terms, water will gain temperature. Okay, it's gonna be used to cool the metal. So who gains water?